and welcome to valves. Two valves that are typically found on bicycles or in the picture here. In this video, I'm going to be talking about the one on the right hand side. Yes, they do have names, Presta and Schrader. Mr. Schrader was the inventor for this one on the right hand side. You might know it as an automotive style valve. That name is convenient because most often Schrader valves are found on bicycles, motorcycles, and cars and trucks. However, that name, automotive style valve, is somewhat misleading because the Schrader valves are used extensively in heating, ventilation, and refrigeration on pressure vessels. That is going to be important later when we talk about the valve cores. But for now, what I want to share with you and focus on in this video is how these valves, the Schrader valves specifically, not the Presta, how the Schrader valves work, what makes them work, what doesn't make them work, and how to care for them. So most often what you'd see just on this is a bicycle inner tube. This is what you see, and what most people are familiar with is you put the pump on it, you put air into the tube or in a tubeless system into the tire, and away you go. And if you want to let air out, you press on the shiny middle part of the valve and then air comes out. That's nice, but let's look at the valve, the Schrader valve, in detail in this video. So, terminology: the valve has caps, one cap per valve, like so. It's easy to mount it, easy to take it off when the valve is clean. When the valve is dirty, then it's more gritty, and then there is dirt and filth underneath. And the point of having a cap on is to keep the valve clean. Any amount of dirt inside the valve will make it useless. You will see it's obvious when I take out the valve core, because there is a core that's on the inside of this valve, and that's removable, and it's spring loaded in the Schrader valve. The core and the cap are mounted on and in the stem. The stem is this hollow metal tube that I've just taken the core out of. I've got the core here separately, and the core removal tool could be looking like this, which doubles as a valve cap. So sometimes the valve cap is your core removal tool, very inexpensive. There the core has been turned or threaded back into the valve stem, yes, and then the cap goes on, very straightforward. Or the core removal tool can look like this, but this is actually a 4-in-1 core tool. This part here is for removing the thread, for removing the core, and the other bits on it are for chasing this thread on the outside, etc. You get the idea. So this is also thread chasing, this is also thread chasing, and this is for removing the core. The Schrader valve has been around for a while, and it says it's been patented April 11, 1893. And that's nice, but why I have this picture here is not to confuse you, because this doesn't look anything like that. That's exactly the point, that this valve has been originally thought of as connecting something and something with a valve, whereas this one is just on a tube or in a rim, just in a tubeless system, because they can be mounted. This brass metal stem, or the whole valve, can be terminated this way, looking like an onion. This is just part of a tubeless system. So this is seated inside the rim, and this is of course vulcanized onto a tube, the bicycle tube. So it could be tubeless or it could be tube and tire. However, again, this is showing an application more akin to using it on a pressure vessel. So let's take a look at the valve core. So the valve core is important. Parts of the valve core is what make the Schrader valve work. So it's got a spring-loaded core stem or a plunger, which is, let me just take it out of this one again. I think this one has a red seal on it. No, this one has a black seal on it. That's okay, but it's gonna work for show and tell. I want to show you this plunging action here. So when you depress the top, this is what happens. Okay, it's spring loaded, and the strength of the spring is what closes this valve core. Now when the plunger is depressed during inflating the tire, you'll see that the bottom here separates and opens up a gap there that the spring quickly closes, opens up a gap there, and that's where air comes in. So the first seal, this black seal, is fairly easy to see. That's the core seal. That seals the whole core to the inside of this valve stem. Yeah, I hope that makes sense. It's fairly intuitive. But the second seal down there, this stem seal at the end of this core stem or this plunger, is not readily visible. It's there, and it's super important. If any speck of dirt gets on this seal, then the core or the valve is gonna leak air. It's fairly obvious. And again, if any speck of dirt gets in there or on the underside of the core there, on that little rim against which this stem seal is seated, like so, then this is not gonna seal any amount of air for any length of time, because these are so tiny surfaces and so finicky. Their condition can change with dirt or deteriorate with dirt. The caps are really important. This is from a textbook, from a refrigeration textbook. So the key point here is that the caps, the valve, the inside components, they need to be clean in order for the valve to work. The core, over time, in the core, the seals will develop a compression set. The elasticity of the synthetic materials or synthetic rubber will work for a while. That's how the seals seal in the first place, but over time these materials stiffen and dry out, and then they set to the inside surface of the valve stem here, and this tiny seal here will set and conform to the mating surface here, the rim of the valve core. So that's what's meant by mating surfaces after installation. So these cores can be changed. They come in a kit. The blue tool is yet another valve core remover tool, and so seals or these cores come with different seals for different materials. Again, this is out of a textbook, you can read it. Different seals are used, or seal materials are used in contact with oils and refrigerants. So that's how they work, that's what makes them work. And bottom line, what you need to do is take your time, take apart, get yourself a core removal tool, take a valve apart, take a look at it. In tubeless systems where this valve is from, you'll see that a tire sealant compound is added to inside the tire, and when you take out the valve core, all the residue from that tire sealant material is gonna be on the valve core. That's fine, that's natural. And of course, these large crystals will eventually seal initially, but will eventually interfere with the providing a proper seal. And if you put them back, of course, the sealant crystals and the ever hardening seal compound will not find the same microscopic surface serrations on the inside of the valve stem and will not seal. That's why they are single use only. So take out the valve core, explore, take a look at these, how they work, and inflate a tire to its specified pressure that you find typically molded into the sidewall of a tire.